All right, guys. Real short video. Somehow that first video I made, the end of it got cut off. I'm not exactly the most tech-savvy person on the face of the earth, but it ends right here, where we are taking the derivative of the cotangent, okay, in this third problem, okay, and off the top of my head, I thought it was the derivative of the cotangent was the opposite of the cosecant squared, and I went to check it, and somehow the video got stopped. I thought I had it all there. So we had it correct. We were in good shape here. Okay, so we are just taking this guy, multiplying it by that guy, and I left it in this form. Okay, clearly you could switch cosecant squared of x with cotangent of x to the power of 3 pi minus 1. You could switch those two guys around if you wanted to. Okay, then we have this, this fourth one down right here. Cosecant of x to the power of 5 times radical, or 5 to the power, I'm sorry, cosecant of x to the power of 5 radical 7. Okay, and again, I had that guy done. I thought it was on the video, but it wasn't. Okay, so again, this guy is just like the previous guy, very similar. Okay, so we let the cosecant of x be our u. So we get 5 radical 7 times u to the 5 radical 7 minus first power times the derivative of the cosecant. Okay, so real easy to do, just using the chain rule. Okay, the derivative of cosecant is the opposite of cosecant cotangent, so it's just a matter of taking these guys, putting it in a usable form. Clearly, you're going to put the negative sign out front. Your constant multiplier, your coefficient, 5 radical 7, and then I brought this cosecant cotangent out front and left the cosecant of x to the power of 5 radical 7 minus 1. I left it in that form. And again, clearly you could switch this cosecant cotangent with cosecant of x, okay, to this power as well. You could switch the order they're written in your answer. Okay, so not a big deal. Okay, so this guy obviously very similar to this guy. Okay, and the last one here, okay, we have this guy right here, okay, very similar to the previous two, okay. Really about the only thing that's a little different is we have this constant multiplier, okay, as a part of u, okay, so that just comes into play when we're taking the derivative of u, but other than that, it's pretty straightforward. So if I let this 3 sine of x be my u, okay, I get 3 pi over 2 times u to the power of 3 pi over 2 minus 1 times the derivative of u. Okay, so this part of it is pretty much finished. Okay, we're done there. And then when I take the derivative of 3 sine of x, obviously 3 is a constant multiplier, so that just goes out front, and I take the derivative of sine and we get cosine. Okay, so right here, okay, we're done with all the nuts and bolts. It's just a matter of putting it in a form that we want it to be in. So I would take this constant multiplier, 3 pi over 2, and this constant multiplier of 3, multiply them together to get to 9 pi over 2. And then I chose to put the cosine of x out front, and then 3 sine of x to this power, okay, 3 pi over 2 minus 1 second. But clearly you could switch these two guys around. Okay, I apologize. Don't know why that got cut off in the video. I have no idea. But that'll sort of be a little addendum to the first video, and it'll be uploaded today as well. You guys be safe.